Today we'll be looking at a very important concept as it concerns circular motion, angular displacement, and angular velocity. Many students are always confused. We're talking about displacement, angular displacement, velocity, angular velocity, acceleration, angular acceleration. You don't need to be confused. When we're talking about circular motion or describing motion in a circular path, every of these terms will be angular. Angular displacement, angular speed, angular velocity, angular acceleration. So let's get to know what angular displacement means, what angular velocity means, and how we can calculate these parameters. Let's look at this sketch on the board. But before we look at the sketch, let's define angular displacement. Angular displacement is the angle measured in radians and the shortest angle between the initial and final point for a given object undergoing circular motion. When you look at this sketch, this is the starting point of the journey called A, and this is a point, another point called B. This seems to be the initial point and the final points. A distance is covered between point A and point B, and that distance is called S. Then the radius is called R. And once this movement takes place from point A to point B, an angle is covered. And that is what we mean by angular displacement. That is what we call angular displacement. And we now define this angular displacement as theta equal to S all over R, where theta is what we call the angular displacement, S is what we call the distance covered on the circular path, and R is the radius. So, if you are asked, or one is asked to calculate the angular displacement, this is what you'll be looking out for. Then next we'll look at angular velocity. Angular velocity is the rate at which an object rotates about an axis. The rate at which an object rotates about an axis is what we call angular velocity. I will define angular velocity omega as theta all over t, because the rates of this movement, time is involved. The rates at which an object moves or rotates about an axis. So we need to know that for an object rotating about an axis, every point on that object has the same angular velocity. But points further from the axis of rotation moves at different tangential velocity than points close to the axis of rotation. So, we also know that angular velocity is also known as rotational velocity or angular frequency. When we are talking about angular velocity, another name for it is rotational velocity or angular frequency. So, when we have what we call average angular velocity, we can say that we have the change in the angle and the change in the time, which you can write as theta 2 minus theta 1 all over t2 minus t1. So, when there's a change between the rate of rotation and the time, we consider that as average angular velocity. And we have what we call the instantaneous angular velocity. Just like when we're describing the linear motion, we talk about instantaneous velocity, velocity at that particular point. Now, if, for example, the limits, we talk about instantaneous angular velocity as limits delta t tends to 0, change in theta over change in t becomes the theta, the t. This is what we call instantaneous angular velocity. The velocity at that particular time, at that particular point. At that point, you are not talking about the change. You're not talking about a change in the angle and the change in the time. So let's look at this problem here. A man goes around a circular track that has a diameter of 7 meters. If he runs around the entire track for a distance of 15 meters, what is the angular displacement? What is the angular displacement? So looking at this, let's look at the parameters. The diameter is given as 7 meters, and then the distance is 50 meters. So what is the angular displacement? So we know that when you have something like this, if this is the center, this is the diameter, and this diameter is 7 meters. So for you to find the radius, in this formula, we have theta is equal to S all over R. So radius, radius is D all over 2. So in this case, we have 7 all over 2, which is 3.5 meters. That is their radius. So therefore, theta is equal to 50 all over 3.5. 50 all over 3.5. So by the time you work that out, you have theta to be equal to 14.28 radians.